Okay, now that we know the different types of ions we may deal with, and we know that we have to put positive and negative ones together, let's talk a little bit more about exactly what this ionic bond is. So, there's two major types of bonds between different atoms. And then the first one we're going to talk about is ionic bonds, which is denoted by a transfer of electrons. All right, that's why you always need a positive and a negative one. All right, so ionic compounds form due to the electrostatic attraction between negative and positive ions. All right, so when these ions form to fill or empty their shells so that they have a full octet, they form these positives and negatives, and those positives and negatives attract each other. Opposites attract. All right. Keep in mind that metals lose electrons to form positively charged cations, and nonmetals gain electrons to form negatively charged anions. So another way you can think about it is your ionic compounds are always going to have a metal and a nonmetal. You do want to remember your group A pattern. All right, so again, if you haven't already, take a screenshot of this. This is something, along with, or you can even, if you have a periodic table that you use, you can even add this at the top so that you remember the patterns, because you will not be given the charge of these ions. You will be told that you're going to deal with chlorine, and you have to know that because chlorine is in group 7A, it'll form a -1 ion. All right, so ionic bonding is this electrostatic force between a positive and a negative ion, and that electrostatic force is created because we always have that electron transfer. All right, so sodium, you can see here, neutral sodium. All right, so this is sodium without a charge. It has one little lonely valence electron in its outer level, and then if it gets rid of that, there's 1, 2, 3, 4, 5, 6, 7, 8 electrons in the next level below. All right, so that's why sodium likes to give away an electron and become Na+. Chlorine, on the other hand, you can see has 1, 2, 3, 4, 5, 6, 7 valence electrons, so it's perfectly happy to take that electron from sodium, fill its shell, and become Cl-. All right, so table salt, sodium chloride. That is the quintessential ionic bond. Something to make note of here. Salt. That term can be used for any ionic compound, not just sodium chloride. So if you see in a question, like which of the following would form a salt, it doesn't have to be sodium and chlorine. It can be any two ions. So just know that that's kind of like lay term or common speak for an ionic compound. So this we talked about briefly, is that the net charge on our final formula, on our final compound, has to equal 0. All right? So sodium and chlorine are really easy because you got +1 and -1. So the formula for sodium chloride is just NaCl. All right? And because we cancel out the charge, we don't have to write those in there into the formula. All right? You just write the atoms. Gets a little bit trickier when you don't have the same charge for each. So when it comes to creating ionic compounds, all right, we call the formula, you'll also see it referred to as formula unit. All right, so that's this, NaCl, the formula. To do that, you first want to identify the charge on your ions. All right, so for example, this is a chemical compound, magnesium chloride. All right, magnesium, the first word is easy. That's magnesium on the periodic table, which is over here. That's going to form Mg2+. Chloride, All right, when we talk about naming in more detail, you'll learn to do this, but the second word always has a different ending. It ends in "ide." All right, so chlorine becomes chloride. So this is going to be chlorine, which is in group 7A, which forms a -1 ion. All right, so when it comes to writing out the formula, your metal is going to come first, always, and your nonmetal will come second. Or really, the positive ion comes first and the negative ion comes second. And then you're going to combine these in the lowest possible ratio to get an overall zero charge. All right? So this one's a fairly easy one. We've got 2 positives and 1 negative. So which one do we need an extra of? We need 1 more chlorine. That way we have 2 positives and 2 negatives. So our formula is going to be Mg. We don't put subscripts when there's just 1, but chlorine, because there's 2, we have to put a subscript 2. Right? You give the sodium oxide a try. All right, so sodium is in group 1A. It's going to be Na+. Oxygen is in group 6A, which is going to form a 2- ion, or a -2 ion. All right, so how would you combine these to get an overall zero charge? Got 2 negatives, 1 positive, so we need an extra sodium. So the formula here would be Na2O. This is the last one. This is the trickiest they get. We got aluminum, which is Al3+, and then sulfide is sulfur, which is right below oxygen, so it's going to be S2-. All right, this one is tricky because it's not as straightforward how to get these charges to cancel each other out. All right, because if you're really good with numbers, you probably already know what to do. But just in case you don't see it right off the bat, you still kind of work the same way. All right, I've got more positive. I've got 3+, 2-. And let me throw another sulfur in here. All right, now I have the problem of I have 4 negatives, but only 3 positives. All right, well, I need some more positive then. So let me throw another aluminum in there. So now I've got 6 positives, 4 negatives. So if I add 1 more sulfur, I'll have 6 positives and 6 negatives, which will give me a formula of, all right, so something I want you to, because we'll run into this quite a bit going forward, is the 2-3 combination. All right, so you've got something that has a charge of 2, something that has a charge of 3. What you want to do is 2 times 3 equals 6. Get both of them to 6, and then that's how you'll be able to figure out how many of each you need. All right. You choose 1 more. I'm going to say choose one from the right side. All right. I'm going to go ahead and pause the video here. When it starts back up, all of the answers will be there, but I will show you how to do each one. I'll write out the charges and show you how we combine them to get them to come to 0. All right. So you want those charges to cancel each other out. A couple of these were written in opposite order. So just remember, when you write your formulas or you write your names, you always put that metal or the positive ion first. So if you've got questions, let me know. But practice will definitely get you more confident with this.